Hello, my name is Catherine and I'm the Director within the Business of Data team here at Crinium, and it is a pleasure to have you joining us today. Driven by our global connected network, Crinium inspires data analytics senior leaders to drive efficiency and innovation and follow proven paths to success. The Business of Data show is just one of the formats that we showcase thought-leading insights from senior data analytics executives. In each episode, we'll discuss the latest industry news and research and explore the hottest topics, challenges and opportunities from around the world. On that note, we'd love to hear from you. If you have thoughts, questions or topics you'd like us to cover in future episodes, please email them over to bod@criniumgroup.com. ModelOps is fast becoming the must-have capability for enterprises seeking to operationalize their AI. And it's all about developing processes for governing, monitoring and managing AI models at scale. In fact, 69% of AI-focused data leaders we polled earlier this year said that improving the enforcement of AI governance processes is a key reason to invest in ModelOps platforms. As AI adoption continues to gather pace in enterprises worldwide, the need to address the operational and compliance challenges that comes along with it will only increase. Today, we are absolutely spoilt for choice with three brilliant executives joining us from Europe and the United States. Joining me first on the show is Gabriele Costapella, who is the Chief Technology Officer for Volkswagen. Welcome, Gabriele.
Hi, Catherine. Nice to see you. Thanks for having me here today.
You are most welcome. It's always a treat to get to chat with you. So I'll jump straight in with the first question. Now, our research shows that organizations are starting to create model operators as a role, with staff dedicated to monitoring and the maintenance behind models in production. Why do you think this is? And is this something that you're currently seeing as well?
Well, I think this has to do with the fact that data science, analytics, artificial intelligence applications are becoming more and more an engineering practice. So people start to, and companies have to move, let's say, from the traditional roles that you see in a proof of concept scenario into something that is more related to traditional software development. So that's why probably many companies are looking into having roles that are completely dedicated to monitoring models in production and making sure that they actually behave the way they are supposed to. So from the one hand, I would say it has to do with this normal and natural shift that happens when you bring new ideas into production. From the other hand, maybe it also has to do with the, let's say, increasing interest and increasing attention to the effects that our models, especially when they are customer-facing, may have when they are applied at scale. Particularly, my personal experience is not having a role like that in our teams. We try to do traditional DevOps. So we have very large teams with many different roles inside, and we try to have the same team that develop the full applications, including the models, trying to also operate and monitor it so that we are sure that the expertise and the experience of the people who have been solving the problem firsthand and from the beginning is available should there be problems, or should there be, let's say, adaptations that are needed in order to make the models that we have in production work continuously.
So I guess, as you've just said, there's that idea of keeping it continuous and having that knowledge on standby. Absolutely fantastic. Now, again, in relation to the research that we conducted, 80% say that difficulty managing risk and ensuring compliance is a barrier to AI adoption for their enterprise. Again, why do you think this is? What sort of challenges present do you see?
Well, let me see that I think that the choice of wording is probably unfortunate in the sense that I don't see this really as a barrier, but I see it as an extra challenge. This is one of the things that I think needed to be done before we can actually put something in production. I mean, risk management, risk assessment, and of course, compliance with regulations is something fundamental. I wouldn't see this as a barrier, as an obstacle, but rather as something that guides us through the development and forces developers and industries, let's say, to take care about some of the specific problems that could happen when these models are adopted in production. My experience is probably a bit different also here. I would say that the biggest obstacles that I see in large companies to adopt or to put AI systems in production is not related really to compliance or risk management. This is something which is standard, and it's done also for any other kind of applications that we usually put in production. But it's more related to basically the fact that most of the AI applications that we have are very data hungry, I would say, so require data from many different departments or many different components of the company, and the fragmentation of the IT landscape might be one of the challenges to bring this holistic view of our data into place so that we can then use it for single applications. Another problem that I see is related, for example, to data quality. Having data quality at scale is a big issue for any system like AI-based system, which is not simply based on static software, but also on ever-changing and updating data. Maybe something else here that I would also see is, well, I just had another thought which I forgot, which one?
Thank you so much. I mean, data quality is such a massive challenge at the moment, right? Whether you are dealing with a large amount...
I just interrupt you. What I wanted to say is related to knowledge of data. This is what was missing. So we talked about data cleaning, data quality, and so on. Another thing that is often very difficult to get in large companies like the ones I have experience with is actually understanding of the data that is used as a source of our applications. And sorry if it is, you can see, it's something that is missing in my head as well. So I was not getting it up first. So, but this is something, the understanding of the data data and of the process behind the collected data is often something that is particularly settled in particular departments, and it is difficult to share. Our experience with our data scientists is that a lot of the time when it's spent in a starting phase of a project just to get some understanding of the data that we have doing data cleaning. Then the real modeling part and the real application development part comes only very later on.
Fantastic. Well, I'm glad you remembered that point because it seemed to be very, very important, and I'm sure the audience will be very glad for you chatting about it. Thank you so much. Now, the other challenges that we did cite within our research include maintaining model audit trails for regulatory compliance and ensuring visibility into the status of models as well. So how are you dealing with both of these challenges, or do you experience them?
Yeah, absolutely. We do experience challenges in this direction as well. I think they touch upon many subjects that are related to observability of our models, explainability of the models that we have in production, and maybe also accountability of companies using AI in production. And these are all things that are let's say, very important at the moment in the area, that are tackled from multiple perspectives. And I have to say, I'm very proud to work in a department that's also doing research in this area. The Data Lab in particular is focusing a lot on finding ways, or is participating in a lot of projects related to explainable AI. So finding ways to, let's say, explain in a human understandable way why a particular model took a particular decision on an input data set. And the other things that we're trying to do, I think it's related to that as well, is related to ethics in the usage of these models. And this is also where we are strongly involved. We try to take part with other companies in the German space to, let's say, find guidelines or general concepts that we can apply into our everyday work so that we can make sure that the systems that we develop and the way we use them is ethical and is not damaging towards our customers, our users.
And ethics being such an important topic, I know as part of your global advisory board role, the networking that you take part in with our global members, it's certainly such a passionate topic that you all discuss together, and something that's very, very interesting for us here at the Business of Data to hear more about. So the last question I wanted to ask you today, again, relating to the research that we did, 69% of those we surveyed say that improving the enforcement of AI governance processes is a key reason to invest in ModelOps platforms. How are you ensuring your governance processes are being followed? Do you think that further investment into ModelOps is the way forward? What's your thoughts there?
This is a very hard question to answer. So from the one hand, I have to say we have, of course, as all the other companies, very strict regulations in place that to ensure that any project that we do, not only in the AI space, but also any traditional software development project, is following all the internal compliance rules that are necessary. On top of that, we have very strong regulations here in Europe related to GDPR that we also comply to. And we have internal, let's say, complex processes, sometimes even very bureaucratic for developers like us who like to, let's say, to go directly to the result of their work, but they are in place. They are used all the times for any kind of project that we use. So I think that this also in traditional companies like mine does ensure that any kind of product that we build, whether it's a traditional software product or an AI-based product, still follows all the rules and compliance regulations. So we have processes in place. This is what I wanted to say. Regarding instead the investments in MLOps or the possibility to use MLOps platforms, I see these as a possible so personally, I see this as a possible solution to the problem in terms that usually these MLOps platforms are made to increase, again, observability of the models and to integrate some ways of explaining models or monitoring their performance over time. In this particular moment in time, our choice is different. So we decided not to invest in platforms. As I said, our IT landscape may be in some cases a bit fragmented, so it might be difficult to standardize on a single platform for the many different problems that we'd like to solve, from deep learning to natural language processing to time series analysis. This is something where we want to keep our, let's say, flexibility into addressing different problems with different tools, just choosing the best tool for the issue that is at hand. What we are investing heavily on is rather in people. So we want to create teams of people who are knowledgeable about these issues, who get what is the extra effort required to bring machine learning models into production. And what we're trying to do is also to increase the collaboration that we have within our teams with teams that have been dealing with traditional software development problems since a long time, so that they are already experienced with all the issues that are related to infrastructure development at scale, monitoring at scale. It can help us bring this knowledge into the development of, let's say, AI-focused products.
Amazing. Well, it's always great to catch up with you, and I'm so glad you're able to join us today. Thank you so much.
Thank you, Catherine, and until next time.
Next up on the show, joining me from London, is Seton Karakas, who is the Global Head of Quantitative and Analytics Solutions from BP. Welcome, Seton.
Hello, Catherine. Thanks for having me here today.
It's an absolute pleasure. It's great to chat to you. It's been such a while since we last connected, but I'm so glad you're able to join us on the Data Show. So let's dive straight into it. Now, when you think about AI production model monitoring, goodness me, what a mouthful. What do you expect that to encompass? And more importantly, what do you expect it to achieve?
Yeah, great question. I mean, there are several things you need to make sure that you're doing. I will start with the most important to the relatively less important ones. First of all, fault monitoring. So there will be errors, there will be warning, there will be, God forbid, there might be even outages in your platform. So you need to have a good fault monitoring system to see what's happening in the computational environment, because some of this model will be very critical for operations of your business. Secondly, you need to obviously monitor the performance. So these systems will run in your models run in certain arrangements. So there might be some sort of timing dependencies. The output of one model might be input to another one. So you need to kind of ensure that those timing arrangements are observed. You might have to monitor the throughput of the executions. So, how many reports are, for example, running, and how many predictions you're able to carry out, etc. Latency is also important. Certain operations have to take in certain time scales. So you need to kind of monitor that, make sure that there aren't kind of any latency issues. And in general, like a flow of the operation, like, I mentioned about the reports, there'll be prediction, there'll be like the calibrations and data processing. So for all of these, you will have certain operational KPIs you will have to monitor to make sure that everything is kind of running as planned. Thirdly, you will probably want to kind of monitor the usage. So you might have different users, different business groups are using your models. So you will have associated KPIs around those. And this could tell you obviously about some of the problems you might be encountering, or some of the overloading, underloading around your estate. And also it could give you some ideas around a certain usage pattern, which you can feed into further development of your new models. If you see, for example, there's a increasing demand in certain group, certain business, you might consider investing in that area. Fourth thing will be infrastructure modeling. So all of these models will obviously run into kind of a compute infrastructure consisting of databases, networks, file systems, all the compute clusters. These things are usually are cloud-based these days, but it doesn't preclude the necessity to monitor them. They might be running by running on the AWS infrastructure, but it's still your responsibility to make sure that they are kind of functioning as they should do. And last but not least, you will need to kind of do a kind of sort of anomaly monitoring. So we talk about the outages and faults, but also certain usage patterns, certain anomalies you observe in the overloading or underloading of certain infrastructure, and also security. So if you see some unusual activities taking place in your compute infrastructure or model environment, then you might have to kind of warn certain people to look into in details. So all of this monitoring, obviously, I think so you ask about so what we expect. I mean, you first have to know about it, so that's the first thing, most important thing. But once you kind of know about what's happening, then the next step would be obviously you can proactively kind of deal with it, right? It's almost like the movie Inception. You could prevent problems before they actually cause you serious trouble.
I mean, goodness me, there's so many things that you're monitoring in that. And then you couple that with the fact that, even if we're just talking AI models, the sheer growing volume and variety of them as well, being in the mix of the elements that you need to be monitoring, especially as you mentioned there about the intended use, the planned use, and making sure that stays consistent. What are the challenges and expectations of being able to manage this growing volume? Is it a team that you're looking for to deal with it, a tool, or is it a case of having multiple teams and multiple tools to deal with this challenge? What's your thoughts there?
Yeah, I mean, there will be definitely multiple teams and multiple people. I mean, none of these things will be done by a single individual, single team. In fact, it's not even desirable that they are being by a single team, because ultimately, with any kind of data analytics platform or system, we try to kind of incorporate the entire knowledge of the enterprise.
Recording stopped.
And bring everyone on board. So there will be by construction there will be multiple teams. So there are a few challenges, obviously. I mean, and there are kind of ways to deal with that. Like, obviously, ideally, you will want to have a kind of a single, unified technology stack where everyone is using the same tools, same system, same programming languages. And this is kind of ideal, but it's not really realistic in a large organization. You could do in a kind of a small organization, just starting up. But in large organizations, different parts of the business will be evolving in different time scales. So, and then, they end up using different technologies. So instead of kind of focusing on the kind of a specific tools, programming languages, etc., I think it is much better to kind of establish, certain kind of common protocols, so that kind of transcends the underlying technology. So a bit like microservices-based service-oriented architectures. So that will be how you deal with the technology. But there are things you could do, even in a big organization, to help with managing this sort of growing complexity. One of the things I will like to call it, you need to have some sort of a unified repository architecture. Like, by that, I mean, like, for example, having a unified data lake instead of you're storing data in different ways. You can make sure that it's all going into the one data lake. You will have the kind of a unified view around the data transformation pipelines, other repository where you store the data, metadata, and your models and the transformation pipelines. So they might be built with different technologies, but that doesn't prevent you to have some sort of a kind of a more unified view how you kind of name them, put them, access them. So you kind of capture all enterprise intelligence or know-how in well designated and well known places. And this leads to the what I call the auditability or auditable extensibility. So you have to make sure that you version everything. Like, obviously, people are very familiar with the source code versioning, but you should do the same thing with the models, pipelines you generate for transforming data, your data sets, and also any execution, any runs, when you do run those models, they need to be versioned as well. So you can actually address one of those execution. Like, for example, if there is an issue, if something failed in the middle of the important process of report generation, you could individually identify that particular run and then go and see what happened. So this kind of auditability is really important. I mean, in certain industries, it's almost essential, right? If you need to explain how certain results have been generated. And also, this kind of forces you a critical architectural feature, which is you kind of separate the parameterizations of your system from the actual technologies or methods you use. So you might have model, but you might have also a model parameter, which is like a data. You kind of keep it separately, so you can evolve them in separate ways. And then and last but not least is it kind of gives you some sort of a composability. So you can basically compose more complicated transformation pipelines and complicated model out of the more existing built ones. So that gives you an enormous leverage, because you don't have to repeat the same thing over and over again. You make sure that when you build something new, it will work as expected.
Certain. You are one of my favorite type of guests, just giving the huge amount of depth there to those questions. I'm sure there'll be audience members that are writing down notes as rapidly as possible to really take note of those. The final question I did want to ask you quickly was, how connected is the monitoring activities to the risk management and governance process and systems? Because I know obviously risk and governance is such a big area of this. So how connected are they?
I think, well, I mean, the answer is should be very high, because if you don't have the monitoring and risk management are not connected, you will ultimately have disconnects and inconsistencies and duplication of efforts. There are lots of issues associated with not having a tight connection. So with risk monitoring, obviously, what I see it is like they end up using the same sort of underlying machinery, whether it's kind of the data or models, transformation pipelines, the visualizations or reporting. They use the same sort of underlying technology or machinery as in the both data analytics and kind of the report you use in the risk management or risk monitoring. So one of the key things here is whether you do this in a kind of real time or more kind of near real time or like a offline, just generations of the report fashion. So, I mean, obviously, as you get more sophisticated, you will do this on almost like a near real-time basis. And also, whether you do this in a kind of more reactive or proactive way. I mean, you will start with doing reactive, but as you get more, sophisticated, more proficient with how you run these operations, then it could be proactive. You could take actions, before you see major issues. And I mean, the key to do all of these is obviously having some rule bases and having all this kind of the protocols kind of codified in those rule-based repositories, so that things not become very kind of depending on who is running certain operations, but they are become more part of the organizational DNA. Mm-hmm. So the governance obviously is similarly very important. Again, I think the main thing here is like it should be rule-based, like codified, instead of like depending on how certain people kind of allow certain operation happen or not. So these rules then can be like it's a bit like a constitution of your infrastructure. So they can be monitored. They can be obviously could be part of the other data analytics activities. So they could both monitor and actually do something useful. So I think this way of kind of having rule bases with the kind of codified rules and protocols, which can be used in both risk monitoring and also actually data analytics activities, is will be quite effective.
Brilliant. Seton, thank you so much for joining us today.
Thanks for having me. Quite enjoyed being here.
And finally, to round off this brilliant episode is Jacob Kosoff, who's the head of Model Risk Management and Validation and the Senior Vice President of Enterprise Risk Management from Regions Bank. Welcome, Jacob.
Well, thank you for having me. I'm looking forward to this conversation. And I'd first like to note that the views I share today are those of my own and not necessarily those of my employer.
No worries. Get that one in nice and early. But don't worry, I won't ask you terribly difficult questions today. So let's jump straight into it. When we're talking ModelOps, there has been a bit of debate recently as to who is responsible or who should be responsible for this. So I've got written here, is it the DevOps team? Is it the IT Ops team, data scientists or compliance? What's your thoughts? Who should be responsible for ModelOps?
A great question. So it's a team effort at any financial institution. So at a bank, at Regions, we partner with model risk, we partner with model developers, we partner with the line of business, we partner with IT. So it's really a team effort. And everyone has a role, right? Especially the model risk team plays a very large role, especially as model risk sets up the guide rails and the guardrails and the framework in which to use modeling responsibly, and sets up the expectations on automated testing and expectations around production and the overall expectations around modeling and data science at a firm. So it takes everybody, and model risk ultimately plays a leading role.
I love that. So it's a team sport. There's not one one organisation responsible for it. Now, a big theme that's come out within most of our content very, very recently is centred around value, return of investment, proving that value. So what is the ROI for ModelOps? How do we justify that investment?
Right. So sometimes it's worth the investment. Sometimes it isn't. So our expectation is that before you build any, say, machine learning model, you do compare it against a statistical model, a benchmark model or a regression model. And in some cases where there is no lift, say maybe in consumer credit, then it's not worth moving to a machine learning environment where there really isn't any increased predictive power, or there's risks of overfitting, or there's overall risks around explainability, and it's just not worth it because there's ultimately no benefit. In other cases where it materially outperforms traditional regression models, or it outperforms business rules, maybe in the fraud space or in the anti-money laundering space, then it is worth it. So I really think it does go case by case.
Brilliant. Now, I know you took part in our bespoke custom ModelOps event recently. Now, one of the questions that came out of that from the audience was, if I'm not in a heavily regulated industry, do I still need to be concerned about compliance? Which I thought was really interesting. So I wanted to make sure we discussed it on the show.
Right. Great question. So for us, a big risk around models are implementation risks and errors, models just having poor predictions and ultimately backtesting poorly and performing poorly. So I think the main reason to have controls around your models is not from a compliance point of view, it's that it's really risky. So the main reason I have brakes on my car are not because I'm afraid I'm going to get a ticket from the police because I don't have brakes on my car. It's because I'm afraid I'm going to crash and die. And the same reason I, make sure I've air in my tires, or that I check my engine and I make sure my car can drive in rain or in sand. It's not because I'm afraid I'm going to get in trouble that my car can't drive in rain or in sand or in snow. It's because I'm afraid it's going to crash and I'll get hurt. So I think the same thing with modeling. I think most concerns around modeling are the same things, is that you might build it for a certain use, and when you go to use it, it doesn't work in certain conditions or in certain uses or in certain cases. And therefore, you really want to have controls around it. I think it's the same thing on model explainability. Even if there were no regulations or you're in an environment that's not regulated, are you really comfortable using a model that just has a high chance of performing poorly and it's hard to diagnose it? So would you ever drive a car where you couldn't lift the hood? And even if there wasn't any regulatory requirements that a car's hood has to be able to be lifted, I personally would never drive a car if the hood cannot be lifted and I can never have a mechanic look at it. And I think most institutions, whether banks, non-banks, would want to use a really risky model or data science product unless they can really get comfort on it.
I mean, I'm a really visual person, Jacob, so that analogy is so brilliant because it really does bring home the fact that you wouldn't drive a car without good brakes and things like that. But also it leans into that explainability behind models as well, right, and the consistency of models. You don't expect the brakes to be in the back seat when you get in the car one time and then the front seat the second, because again, you have that understanding of how that should work going forward. So that's such a great analogy. So thank you for bringing that one to the show. So my final question to you, I know you've spoken through some of the key risks of the AI programs. But how do you measure them? How do you measure those risks, and what is worth taking for the innovation and the progress that it's going to build and bring to your organization versus the risks that are going to be detrimental?
So I think on each model, you have to really think through how the model is predicting an output. So I'll take a classic example in the banking industry. In February of 2020, most fraud models, that is models designed to predict if a transaction, a debit card transaction or credit card transaction, was fraudulent. The main variable in the machine learning models, the most predictive variable, the feature with the most weight in a fraud transaction model was the customer's history of card present to card not present and the customer's current transaction. So if the customer, like my mother, 95% of her transactions with her credit card or debit card, she was present. She was at the supermarket. She was at the store. Then COVID hit. And all of a sudden, my mom started doing transactions online. She started doing online shopping at stores and at times in environments she had never done online. So, of course, these machine learning models in the financial crime space at financial institutions predicted those transactions were fraudulent. Now, of course, they weren't fraudulent, but the environment had changed because of COVID-19 and the resulting pandemic and safer at home and stay at home orders and lockdowns and so forth. So this was a clear failure of machine learning models that swept the banking industry in the US and worldwide in February and March of 2020. Models to predict transaction fraud failed in the industry in March of 2020. And so what firms did well? The firms that had really strong model risk management programs that in February of 2020 and early March of 2020 saw this coming. They, even if their own geographic footprint didn't have stay-at-home orders and didn't exceed their behavior, they could buy data from Italian banks from Washington State, from banks in New York, and banks in other areas that were hit by COVID earlier and had those patterns change where people shifted to online transactions earlier than other regions, and they were able to re-estimate their data with this new pattern. And so the banks that were the most successful with their machine learning ops and their model ops approaches were those that were nimble and had creative and thoughtful, I think really the word is creative data scientists and creative and thoughtful and questioning and even skeptical model risk experts to say, whoa, we need to re-estimate this fraud model. And unfortunately for some of the lagging banks, it wasn't until April of 2020 where they re-estimated their machine learning models for fraud. And they were too late to the game to recognize that a card present to non-card present ratio was no longer predictive for determining if something was fraud. So we see these examples all the time in credit, in anti-money laundering, in marketing, in the models that predict how much cash needs to be in an ATM. They, of course, stopped working in March and April 2020. Models, how many people you need in a contact center, models for customer behavior and customer needs. So many models fell apart in March of 2020, and they really proved the point that there is a material risk from overfitting models, and model risk management teams really ultimately saved the day in this and March and April of 2020. And so I think that was a good opportunity unfortunately, there was a pandemic, and it was horrible for the world. And financial institutions and other institutions really learned the real crucial need of risk management during that time.
And I think that's such a great example because it really draws out, for me, two real key things here. So it shows the model and the way that it's being worked has a direct impact on customer experience and the customer success department, because you're going to have customers who are going to be stressed. They need to buy this item online really quickly, but I can't access my money and now I've got to call up the bank or whatever that process might be. But then the second, doesn't that drill home the amount of skills that are behind these model operators, as you say, to predict and see this coming and being able to act to reduce down that impact on the customer and the business, and to keep it rolling in very turbulent times. And as we know, that talent pool is very, very hard to access. So goodness me, what a proof of value they certainly had. Jacob, as always, an absolute pleasure chatting with you. Thanks so much for joining me.
Oh, thank you so much for having me, Catherine. I really enjoyed it and looking forward to future episodes.
There we go. What a brilliant episode. Thank you again to our thought leaders for their fantastic contributions. Next time, we'll be talking all about the cloud. Just as we have done this time, we'll be joined by expert thought leaders to help us dive deep into the challenges and opportunities. Be sure to subscribe to the Business of Data YouTube channel, follow our page on LinkedIn, and visit our content platform for more great content, insights, and connections. Stay safe, stay well, and we'll see you next time.